Hi students, in this video I'll be going through the 2018 Additional Mathematics Paper 1 question 8. Right, so this is a question regarding trigo identities as well as trigonometric graphs. Alright, so let's read part 1 of the question. So they want us to show that 8 sine square x plus 2 cosine square x can be written as a plus b cosine 2x. Alright, so basically what they want us to do is they want us to transform this equation, this expression, right? Okay, uh, 8 sine square x plus 2 cosine square x into a form that consists of the double angle for cosine, right? So the moment that you see something like this, okay, you should get a clue that you may need to make use of the double angle formula for cosine. All right, so the double angle for cosine exists in three forms. So the first form is cosine 2x equals to cosine square x minus sine square x. So this is the first form. Right, then the second form is cosine 2x equals to 2 cosine square x minus 1. And then the third form would be cosine 2x equals to 1 minus 2 sine square x. Okay, so it exists in these three forms. So basically, if you look at what they want in the end, okay, this expression does not have sine square x or cosine square x anymore. In other words, we need to try to substitute away the sine square x and the cosine square x from the original expression. Okay, and then we try to express everything in terms of cosine 2x. Alright, so we can do this actually quite easily. So for example, like from the second form of the double angle formula for cosine, number 2, what we can do is we can bring the 1 to the left side. So we will end up with this, okay, cosine 2x plus 1 equals to 2 cosine square x. So can you see or not? Now this 2 cosine square x over here, we can replace it with cosine 2x plus 1, right? We can replace it with cosine 2x plus 1. Okay, then we can do likewise for this using the third form of the double angle formula for cosine. So if we bring the negative 2 sine square x to the left side, so we will get this. So it becomes positive 2 sine square x, right? Okay, then we bring the cosine 2x to the right side, then we will have this expression already. Okay, so 2 sine square x is equals to 1 minus cosine 2x. Okay, but over here is a 8 sine square x. So what we can do is we can multiply everything by 4. Okay, so this one will become 8 sine square x. Okay, but then the right side must also multiply by 4. So it becomes 4 minus 4 cosine 2x. Now we can also substitute this one over here. And the entire expression will then have no more sine square x and no more cosine square x already. Alright, okay, so that's basically what we're going to do. Okay, so we're going to replace the 8 sine square x with 4 minus 4 cosine 2x. And then we're going to replace the 2 cosine square x with this one. Okay, we're going to replace it with this one. Okay, because 2 cosine square x is cosine 2x plus 1. So we replace it with cosine 2x plus 1. Okay, so you can see now we have achieved the objective already. Now the expression is totally in terms of cosine 2x and another integer, right? So if you simplify it, you will get 5. Okay, negative 4 cosine 2x plus cosine 2x, you will left with negative 3 cosine 2x. Okay, so this is the form that we want. In other words, if you compare, A will be 5. Okay, so this will be 5. And then B will be negative 3. Right, so actually this is not a very difficult question. So you need to take the cue from what they want. If they want an expression that is cosine 2x, then you start to think about the double angle formula for cosine and how you can substitute away the sine square and the cosine square. All right, so it's actually not that difficult. All right. Okay, so state the period and amplitude of this one. Okay, so we have already expressed 8 sine square x plus 2 cosine square x, right? Okay, in the form of this 5 minus 3 cosine 2x. So in other words, they're asking you if you were to draw this graph, okay, y equals to 5 minus 3 cosine 2x, right? Then what is the period and the amplitude? Right, so we know that for period, okay, for period, okay, where we will look at is this number over here. So if this number over here in front of x is 2, right, it means that from 0 to 360. Okay. Okay, for this question, we are working in terms of radians. So if you refer to part 3 of the question, okay, that means from 0 to 2 pi, you will see two complete waves. Okay, so if 0 to 2 pi has two complete waves, it means that the period which is a time for one complete wave, right, will just be pi. Okay, if 0 to 2 pi is two wave, that means 0 to pi one wave, and then pi to 2 pi the second wave. So the period will be pi. Okay, anyway, if you want to find a way to calculate out, what you do is you always take 360 or 2 pi, then you divide by the number in front of x. So if the number in front of x is 2, right, then the period will be 2 pi over 2, which will be pi. Okay, so this will be the period. Okay, then the amplitude, okay, is also very easy to identify. Okay, the amplitude will just be the number in front of the cosine or sine function, right? So in this case, it's a 3. Okay, you don't have to bother about -3. Okay, -3 will just affect the shape of the curve later. Okay, but for amplitude, we always write as a positive number. So the amplitude will be 3. Okay, so do keep in mind, okay, we need to make use of these two info for the next part. So period is pi, amplitude is 3. All right. Okay, so the next part, they ask you to sketch the graph. Okay, for y equals to 8 sine squared x plus 2 cosine squared. So we have already expressed this as 5 minus 3 cosine 2x, right? Okay, so in other words, they want us to sketch this graph. Okay, y equals to 5 minus 3 cosine 2x. Okay, so the method that I always use to sketch a graph is I always set up the vertical shift or the center point. Okay, and then after that, set up the minimum point and the maximum point. Right, so where do we get the vertical shift? The vertical shift will be looking at here. So this will also be what I call the rest point of the graph, okay, the center point of the graph. So which means that this marking over here is 5. Okay, so over here is 0. Okay, so 5. Okay, and the amplitude is 3. Okay, the amplitude is 3 means the maximum point will be 5 plus 3. Okay, which means that it's going to be 8. And then the minimum point is going to be 5 minus 3. Okay, so it's going to be 2. Okay, so I always set up these 3 points. Okay, then remember for this graph, because it's 2 here, so the period is pi, right? Okay, so the period is pi. Okay, so I'm going to mark out pi over here. Okay, but they want us to draw until 2 pi, right? Okay, so if the period is pi, what you do is you want to divide this 0 to pi, right, into 4 equal parts. Okay, so you're going to divide into 4 equal parts. So 1. Okay, so now you see it's 4 equal parts, right? Okay, then this point will be pi over 4. Okay, because you divide pi by 4, right? Okay, then over here will be 2 pi over 4, which is pi over 2. Okay, then here will be 3 pi over 4. Right, so now we have the 4 markings. Okay, we are able to draw the first half of the graph, which is the first cycle. So remember, if the period is pi, that means within 0 to pi, you already have one complete wave. Okay, so now we want to be careful over here. Here is a negative cosine graph. Okay, for a positive cosine graph, the shape will be like this. Okay, so this is a positive cosine graph, right? So positive cosine graph will start at the maximum, go to the rest point, go to the minimum, go back to the rest point, and then go back to the maximum. Okay, but for negative cosine graph, we'll just do the opposite. Okay, negative cosine graph will be like this. Okay, so you will go from minimum to rest to maximum to rest and then to minimum. Okay, so this is the negative cosine graph. Okay, so the minimum point is 2, right? Okay, so the minimum point is 2, so we'll start at here. Okay, then after that at pi over 4. Okay, so use your ruler and go up, right? So the next point is here. Okay, the maximum point will be at pi over 2, so somewhere here. Okay, then go back to the rest point over here, and then go back to the minimum. So we are able to now sketch the first cycle. Okay, so let me try to sketch a nice graph. Okay, so it's easier to sketch on paper. Okay, so this will be the first half of the graph. Okay, then the second half will be from pi to 2 pi, right? So roughly around this distance. Okay, so 2 pi. Okay, so same thing, divide it into 4 equal parts. Okay, so it'll be good if you can use your ruler to measure like 1 cm for each interval. So after pi, you have add another pi over 4. So here will be 5 pi over 4. Okay, then 6 pi over 4, which will be 3 pi over 2. And then 7 pi over 4. Right, so then we'll continue after minimum. Okay, after minimum, go to rest. So over here, it's going to go back up over here. Right, then after that, go to the maximum over here. Then go to the rest over here. Then finally go back to the minimum. Right, so let's try to sketch it nicely. Okay, so here should go through the point. Okay, so this will be you can see there's two complete cosine graph. Right, so from 0 to pi, you have one complete graph. Okay, because the period is pi. Then from pi to 2 pi, you have a second graph. Right, so if you recall how to sketch a graph well, draw the axis. Okay, set up the center, the vertical shift. Okay, then after that, use the amplitude to find the minimum and the maximum. Okay, then set up those two lines. Then after that, start to mark out. So if the period is pi, you mark out pi first. Okay, if I leave some space to draw the rest of the graph from pi to 2 pi lah. Then if the period is pi, that means for pi, you divide the interval into 4 equal parts so that you can mark out all these points, and then after that you can draw the graph. Right, so just take note that for negative cosine graph, then the shape will be like this. If it's positive cosine graph, then it looks like this. Right, so the same thing applies for sine. If it's negative, then you invert the graph. Right, so this is actually quite a manageable question lah. Okay, so do more practice and you will be familiar with it. Right.